Okay, hi everyone. Thanks very much for joining our webinar today. My name is Joanna Wilson and I work in the Scottish Renewables team at Energy Saving Trust. Today's webinar is going to focus on smart homes, which might be a relatively new area for a lot of us, so it should be quite interesting. And it's part of a series of webinars that we're delivering, and that work's funded by the Scottish Government as part of their support for home renewables and energy efficiency. And that's there to help lower Scottish householders' energy bills and carbon emissions, meet climate change targets and build a lower carbon economy. That said, even if you're located outside of Scotland, I think you'll still find the subject matter of interest, so stay on the line. And before we start, I'll just give a couple of sort of general housekeeping points about the webinar, just in case you've not attended one of these before. The first thing is, you can hear us hopefully, but we can't hear you, and that's perfectly normal. So don't worry about background noise or having the radio on or anything like that. We're also recording the webinar and we'll send you a link to it afterwards. So if you missed something or want to look back at something later, that's absolutely fine. Because we can't hear you, you can't ask questions verbally, but if you look at the right-hand side of your screen, or it might be the left-hand side possibly, you've got a little control panel, and there's a little tab called questions, and you can just type in a question and only we'll be able to see that. Other attendees can't see that. We're also expecting the webinar to last approximately 45 minutes, sort of give or take. And we've got quite a full agenda because we've got 3 speakers, but if we've got time at the end, we'll maybe have a look at some questions if possible. So our agenda for the day, you can see up on your screen now, is first of all, we're going to have Dr. Jon Stinson from the Scottish Energy Centre at Edinburgh Napier University, and he's going to give a sort of overview of smart technology. He's a bit of a smart technology expert. And then we've got Sofie Rogers from IKEA, so we'll all be familiar with her place of work, and she's going to talk to us about smart lighting. And then finally, my colleague Brian Horne, Knowledge Manager here at Energy Saving Trust, is going to talk about smart heating controls and the potential there. And then finally at the end, a bit of Q&A if possible, and we'll also let you know about our next webinar that's coming up. Okay, so I'll just pass over to Dr. Stinson now.
Great, thanks, Joe. Yes, I'm Jon Stinson, a research fellow working within the Scottish Energy Centre, which is part of the Institute for Sustainable Construction at Edinburgh Napier University. So this is the structure of the presentation. I'm going to provide you all with some background to our research on smart home and smart home technology, then discuss the definition of the word smart in context to a smart home. Then I'll reference a range of smart home technology, how they communicate with one another and between each other and to the user, and finally how this technology relates to your energy consumption profile. The smart home and energy technology research in the Scottish Energy Centre began in the early 1980s, but more recently I've been closely involved from 2007 when the first intelligent meters, now called smart meters, were being trialled in homes across Scotland. Since then, our academic research and R&D work around smart homes has progressed through real-time displays, now called energy monitors or in-home displays, domestic energy behaviour change techniques, to investigating temperature and humidity levels in relation to people's comfort, and developing energy benchmarks for the variety of different housing archetypes in Scotland. From the start, all of our research possessed a psychology and sociology component, by which we use surveys and interviews to involve the energy user and household occupants within our research. And this has shaped our understanding of the human experience within the domestic setting and the effect of graphical user feedback mechanisms for smart homes. Right, so what is smart? And in many respects, smart is a catch-all term that's applied to almost any product on the market today. And it is the successor to the word intelligent, or the letter I we've seen in the late 90s and early 2000s. So when I say something is smart, certainly in relation to this presentation, I mean technology that's connected over a wide area network and or over a home area network. So these devices are connected to one another, and they present the user with greater insight and or ability to manipulate their environment. And certainly over the past decade, we've witnessed a wide spectrum of smart home technology arriving on the marketplace. And broadly speaking, we can aggregate these technologies into 3 clusters. So there's technology that shows the user or grants the user controllability of aspects that enhance the home's atmosphere, like the acoustic levels, thermal performance, air quality, luminance performance, etc. Technology then that provides greater protection or surveillance over important items, pets, family members, etc. And technology that replaces existing home appliances, which then provide increased functionality and optimize the user's interaction time with these appliances. So all of this tech can work really well to increase the user's awareness for a discrete element of the home, which is great. But this often means that for each piece of new smart home technology, the user also has a new gateway or a new hub, and which then connects that piece of technology to a smartphone or a smart tablet, which then comes with a new app to view and control the technology. And again, this is great until you have smart cameras, smart energy monitors, smart lights, smart thermostats, all from different manufacturers, all have their own gateway, and all have their own app or user interface. So the lack of interoperability between technology was one of the largest barriers to the uptake of the smart home concept and smart home technology for most users. However, things have changed. More recently, we've seen the biggest names in smart home communication technology start to talk to one another. And now we have agnostic hubs and cloud-based routines which augment the technology onto one app or interface. And the caveat here is once you port non-native hardware onto an agnostic ecosystem like a hub, then you inevitably lose some control over the tech's more finer functionality. But this is by far often a price worth paying just to get all the variety of different technology onto one single app and user interface. So certainly having a single point of contact for all things smart in your home is a surefire way to streamline the quantity and quality of the notifications that you receive, which, if not optimized correctly, the amount and timing of notifications can become the next big barrier for people to disengage from smart home tech. So when smart home technology first arrived, our relationship with it was very much pull. And by this, I mean that we sought out the technology to tell us something that we didn't already know. So in the example of the in-home display or the energy monitor, the user would have to go to the device's graphical user interface and manually query the tech for answers on how much energy they were consuming, or money they were spending, or CO2 they were emitting. And all of this initially was done through monochrome numerical interfaces, which really isn't the best way for anybody to learn about anything, least of all about their levels of energy consumption. But again, more recently, the energy display industry have learned a lot and evolved a lot, and those still working with graphical user interfaces have improved these by making them colorful and vivid, using less text, less numbers, less graphs and charts, and using more RAG mechanisms, which is red, amber, green, and other glanceable instantaneous feedback methods like smiley and frowny faces. So we've also seen a big jump into real controls and smart automation. For years, the industry were using words like control, but this was still heavily dependent on a human understanding what the display was telling them, knowing what to do about it, and when to act. And this is a very flimsy proposition for most of us. But now, through the interoperability of smart tech, through hubs and smart routines, we are seeing the tech taking control of our environment based upon what we want them to do, based on what we want to achieve with the preset rules and routines that we have set. And even more exciting is the integration of verbal user interfaces. So these are chatbots that and certainly captured our imagination and our attention in a big way over the past couple of years. The communication protocols for the big three players in the chatbot market are in a race to make their system as interoperable as possible. And it is becoming a very exciting time when you can verbally speak to your home and ask it what temperature is it in the bedroom, or how much money have I spent on electricity this month. Right. So, however, energy monitors in many respects are still playing catch up with some of the other more smart tech, especially smart lights and smart heating and smart smart security systems, which is unfortunate because, and there's many reasons for this, which are probably for a different webinar, but thankfully we are seeing the big four independent in-home display developers stepping up and into this void. So we have technology, we have smart technology that directly affects your home's energy consumption, and these are smart tech in the appliance cluster. Then we have tech that are sought after for entertainment value or their ability to enhance our atmosphere. These have an indirect effect on a home's energy consumption. And we have technology that provides us with some level of accessibility and control. And regardless of the other hubs that connect with your home, it is still the in-home display or energy monitor that is the real hub of the home for energy optimization. This means for energy optimization that the user or the occupant is still the most important part of any smart home system. Right, so I'm going to show a graph that some of you may be familiar with. So let's take a look at the energy consumption profile for the home. So for those of you who have recorded your energy consumption for a day and you've looked at it graphically, this might look very familiar. So I'm going to talk about two of the major elements that make up a home's energy consumption profile, and these are the baseline and the peaks. The baseline relates to the energy consumed by the home under normal or common operation when the occupants are sleeping or out of the home or otherwise not consciously using energy. So to put this in context, appliances that typically use up the baseline, make up the baseline, are appliances that operate for most or all of the day, regardless of human input. So for most of us, that will be our heating system during the heating season, the winter periods. The fridges, they're two very good examples, but also if you're in a more modern zero energy or low carbon home, that could be something like an air source heat pump, or also something like a mechanical ventilation heat recovery system that the house requires to run continuously for the internal environment to remain comfortable. The other main sources is the energy consumed by appliances on standby, and these are often referred to as phantom loads, meaning that it may look like the appliance is dead or turned off, but it's still consuming energy and still costing you money. And without a doubt, recording and seeing a historical view of your energy consumption is one of the ways to understand what's going on in your home, especially when you're not there or you're not awake. The graphical user interface for most energy monitors are still relatively good at doing this. But what is what we do next after seeing the data, that is where most of the smart display technology drops off. And the energy savings become very dependent on one's own knowledge and willpower. However, smart fridges and smart variable compressors, smart TRVs, that's your temperature regulating valves at the end of your radiators, and geofencing with smart thermostats and smart plugs that kill devices on standby. These are all areas which really change the baseline of your home's energy consumption profile. So for the peaks there of your energy profile, there are two things. You can reduce them or you can shift them. So reducing the peak is something best facilitated again by an energy monitor that shows you your consumption in real time. And again, there are many energy monitor providers that do this very well. Energy awareness and knowledge and knowing what, when, and how to change your energy and use behavior are still the two most powerful methods of reducing the peaks. But I know that we're all bored of hearing the words behavior change, so technology thankfully is here to help us again. So setting routines through our hubs will allow your smart home tech to manipulate your environment based upon set rules, conditions that you provide. Plus the emerging smart shower range is doing a lot to help users reduce their time in one of our single biggest energy consumers in our homes. So if you can't or don't want to reduce your peaks, then consider the integration of smart technology, renewable technology like solar panels. So before everyone moans and turns off, you hear me out here. Okay, the government's financial rewards have for solar panels is almost completely gone, and declared payback is very unattractive. However, those figures and those calculations are based under normal energy use. And now we have smart technology like dishwashers, robot vacuum cleaners, washing machines, which will offset the energy consumption so it occurs during a peak energy generation time, which, depending on the appliance and the time of year, they could cover the majority or all of the energy demand from those appliances. And we have solar optimized water heaters, which divert the power that you would be sending back to the grid into a water tank to preheat the water, so you use less gas or grid electricity. And quite basically, water tanks are a low-tech answer to batteries. So that was a quick overview of Edinburgh Napier University, of smart home technology and the research that we've been doing, and how that applies to what you might be experiencing or considering by embedding smart technology into your home. So thanks for everyone for your time. I'll pass back to Joe.
Thanks for that, John. That was really interesting. And some of what you said about behavioural change actually did strike a wee bit of a chord with me, unfortunately, so I should maybe look at some smart tech reminders. I'm just going to pass over now to Sofie from IKEA to talk about smart lighting.
Hi everyone, great to be here. Thanks very much for having me on the call today. So what I'm going to be talking about is IKEA's smart lighting. Now, I'm sure most of, if not all of you, will hopefully have paid us a visit at the store in Edinburgh or Glasgow, wherever you happen to be based, even up in Aberdeen. But I think smart lighting is quite a new one for us, and it was really great to hear Jon talking about user interfaces and things like that. So we'll cover a little bit about that in this presentation as well. But I kind of wanted to talk a little bit more about light in general, just to start with, because I mean, light is so fundamental to life on so many levels, but it's really, really important. It makes a home function better and everyday activities easier. You know, for everything from, you know, cooking to doing homework. And I think especially in Scotland, and particularly in the now we're coming out of the darker winter days into spring, it's always lovely to see more light. But it's not only important for people's health and well-being, but it also creates a lovely kind of atmosphere and, you know, a sense of kind of safety in your home. It's a really personal sort of choice as well, because where, what type, how strong is you know, a very personal choice for people. IKEA believes in kind of good lighting, you know, being the Scandinavian company that we are, but also that it shouldn't cost the earth. The key thing about our lighting range is that it's all LEDs. Now, I'm sure lots and lots of you will have heard about LEDs before. They're not obviously the same as energy-saving bulbs, you know, that take ages to turn on, or, you know, do you know, give off that kind of really yellow light. They do have a really amazing positive impact on your energy bills. I actually personally changed most of my light bulbs in my flat to LEDs last year. I changed all my big 60-watt downlighters in my kitchen and some other ones, and it saved me about £200 on my energy bill when I got my bill last month. But obviously today we want to talk about smart technology. So I'd like to introduce you to Trad-free. Apologies, I don't think it's the proper Swedish way to say it. So apologies for my terrible pronunciation. But this range is part of our smart lighting launch, and it's IKEA's second step into IKEA Home Smart. And the first kind of wave of this started in April 2015 with the launch of wireless charging products for mobile phones. So we had originally a mobile phone charging pad that was integrated into a like bedside table and light combination. We had another one for a bedside table, and you can buy them individually to put, you know, in counters in your kitchen or places that you kind of commonly charge your phone, but they don't need cables. Now, if anyone has an induction cooking hob, it works in a very similar way through magnetic charging. And IKEA's Home Smart is not about making chargers or gadgets or apps. It's really just about adding functionality to the entire IKEA range by integrating technology into our home furnishings offer. And smart lighting is one way that we're using technology to improve people's lives at home. I mean, ideally, what you'd want to have is a kind of cozy family dinner. The lights are on kind of soft, quite neutral, and a warm kind of light. But then after tea, you've got the table cleared for homework, and that calls for kind of proper, clean, bright light in quite a direct way. And trad-free was our solution for our customers in this way. So smart lighting isn't new, but it's also never been so accessible for people. It really, price shouldn't be a barrier for people. And our design team at our kind of head design office in Sweden, they actually, as a team, made themselves a commitment that they wouldn't charge more for this bulb than they themselves were actually willing to pay. So we really don't want price to be a barrier for people. And the great thing is that the range is made up of products that can be combined to create a personalized kind of home lighting solution. So it includes LED bulbs, these cool panels and cabinet doors that can be controlled by either a remote or an app. You can dim them, you can change the tone of the light from warm to cold, and you can control everything via the remote or the app. And the good thing is you can get a starter kit from IKEA, and then you can kind of add as you need. So it's a bit of a mix and match solution. And the good thing about the smart lighting stuff is that you don't actually need wires. So it's just, the same as changing a regular bulb would be. So I just wanted to give you a little bit of a example of the app. So really the screen itself is just a really simple interface. You can just touch control, so you can slide the scale from left to right. And what that does is it makes the room kind of the tone of the light. So you go towards the softer side of light, which was what we call a more yellow light, or you go towards the kind of slightly cooler light, which is these kind of slightly more blue lights. And that sort of control also means that you can do everything in one room just through your phone. And there is also a remote control that you can use. My favorite part of the smart lighting aspect is that you can set it as an alarm to wake you up. So you can have this really, your lamp can be just off at night, and you can have this lovely kind of slow, kind of warm light to wake you up that turns on slowly as part of your alarm, which is definitely my favorite part, not being a super morning person. So I think it's a really simple and straightforward way to use this technology. The good thing about it is that you can, in some of the bulbs, particularly if for kids' rooms or the man caves amongst us, you can do a really cool setup with LED bulbs that will actually change color. So you can change them through the whole color spectrum from yellow to blue to to purple. So it can be quite a lot of fun. So the good thing about sort of smart technology is, and John touched on this earlier with regards to lots of different companies having lots of different interfaces, and I think we still are kind of slightly on that journey. But we were kind of super excited to partner up. So we're now compatible with the Alexas, the Apple Home, and also Google Assistants. And so the great thing about it is that you can now voice control this smart lighting. So you can just say, Alexa, turn on the lights in the kitchen, and everything turns on. And that's a really kind of exciting aspect, because it just makes, if you've got shopping bags, or you've got the pushchair and you're carrying another little one, you can just say, Alexa, turn on the lights, and everything works in one go, which the simplicity of that appeals to me a lot personally. And I think our next kind of exciting collaboration will be with Sonos to create kind of products and experiences that make people's homes look and sort of sound amazing. So we're really excited about that, and that will be kind of released into the stores in 2019. So you guys are getting a sneak snapshot. So thank you so much for having me on the call today, and I'm going to pass back to Jo for now. Thanks.
Thanks for that, Sophie. That was really informative, and I've got to say I can also testify to the brilliance of an alarm clock that just wakes you up with a gentle light that gets brighter. That's good. I'm just going to pass over now to Brian Horne to talk about smart heating.
Hello there, thanks for joining us. Yes, I want to talk about smart heating controls because to my mind this is one of the great potential areas for smart technology in the homes, something that will help us and will help us save energy, but also where there is a lot of potential for more work to be done compared to what there is out there now. I'm going to start by looking at what features are currently available, as far as I'm aware, in the range of smart heating controls, smart thermostats that there are out there, and look at how useful those are. And that's inevitably going to be a fairly subjective view in terms of how useful I see them as being and whether or not I would like them. But I also want to look at whether they will actually help us save energy and carbon in a more objective way. And I will be looking at taking a quick look at what the future might hold. Not really predicting, because that would be foolish, but looking at areas where I hope that these things will develop and provide more help to us in our homes. Right, smart heating features. To my mind, there are sort of four broad groups of features that are available at the moment. There are systems, as I'm sure you're all aware, you'll have seen the adverts on the telly, that you control your heating from your phone. Great, or a tablet, or from anywhere else. There are heating systems, this isn't perhaps so widely advertised. There are systems that provide additional heating control functions, and I'll talk about what those are in a minute. Some of the smart systems claim to be able to learn from the inputs and to make changes as a result. And some of them will interact with other home control systems, as Jon was talking about in his presentation. Right, control from your phone. This gives you remote control, like in the adverts. If you've gone out, you've left the heating on, you can turn it off from your phone. But it can also, it is one way of having central control. You can control more things from one place. Wherever you are in the home, you can control them. And it does give the potential for a better interface. But I know for what one person's better interface is another person's worse interface. I hate controlling stuff from my phone, but I'd be interested in controlling it from a tablet. Other people, it's different. Some people, their best interface is a dial on the wall, and we do need to remember that. If that's what people want, then that's what people need. But having remote control doesn't in itself save us energy and money. It could under certain circumstances, maybe, but that's not really what it's about. It's about making a new way to control heating, which some people might prefer. Additional control functions. This is a bit more techy, and some people could have some of these and not even know it. There are four groups of these really that I'm aware are being introduced. Automation is this is a system that turns your heating on and off depending on whether it thinks there's anyone in the house or not. We're familiar with this with lighting, particularly in offices and places like that. But there are systems that can work out whether there's anyone in the home, and if there isn't, it'll turn the heating off or down. There are systems that can work out because of where your phone is that you've nearly got home, and so it can turn the heating on ready. Optimization is the second one. This is a system which works out when to turn the heating on in the morning and when to turn it off in the evening. Most of us get by guessing. We think if I've got to get up at 7:30, then I'll set the heating to come on at 7, and hopefully the house will be warm by the time I get up. Optimization is a system that does that automatically based on the temperature outside, the temperature inside. It's common in non-domestic buildings. It's been available in theory for homes for many years, but not in practice being incorporated very much. As with the next two, load compensation. What load compensation does is it looks at the temperature in the house, the temperature it's supposed to be at, how hard does the heating system need to work, and it turns your boiler down a bit if it can, which saves a bit of money. And weather compensation does a similar thing, but it looks at the temperature outside the house. If it's a really cold day, it turns the boiler temperature up. If it's a mild day, but you still want heating, it turns the boiler stat down. Those last three, they're all available for commercial buildings. They've been in theory available for homes. The reason we don't have them in our homes is with using traditional equipment, it costs you a couple £100 to add each one. And it's just not worth the money for the small amount of saving it gives you. With smart controls, you've got most of the stuff there anyway. You've got temperature sensors, you've got controls over all the heating elements anyway. To add these functions, all you need to do is write a little bit more software. So the cost of adding these functions to an existing smart system is very small, so it makes a lot of sense to have them. Learning. There are systems available which claim to learn from the inputs and improve the performance as they go. And I'm sure this is true to an extent. They will look at inputs from the building and the heating system. In fact, any optimization system has to do that or it won't work. It looks at how quickly it takes the building to heat up from cold, and it makes decisions on the basis of that. So it'd be different for different, put the same system in a different house and it will make different decisions because the house performs differently. They can also learn from your inputs. In other words, when you make changes to the heating controls, it remembers that, and if every Tuesday morning you try and make it come on earlier than every other day, it works that out. It says, right, these people get up early on Tuesdays. It interprets the controls, interprets these changes to control the system to provide the environment you want. This is a huge area as far as I'm concerned. I'll talk about the potential in a minute, but I think there's a lot of potential here for better control of home heating through learning, through artificial learning. And then there's interaction with other systems. Jon talked quite a bit about this in his overall presentation. A heating system can interact with a security system. There are people offering this now. Fundamental principle is if you go out in the house and leave it empty, you probably want the heating off, you probably want the door locked, you probably want the alarm set. So why not do all three at once? Similarly with the lighting, you may want the lighting off, you may want the lighting to come on and off in certain rooms to make the place look occupied. Ventilation. There are systems available which will interact with a humidity sensor and control your ventilation at the same time as controlling your heating. But there's quite a lot of potential, I think, for doing much more with that, which I'll talk about in a minute. AV equipment. I think the main reason that heating system might interact with your AV equipment is that people may well be buying smart systems to control their radio to listen to music, and we don't want to have too many systems. It's not an exciting area as far as I'm concerned, but it's just part of the fundamental principle that if you've got a smart home, you want to manage the way you interact with it to make it an efficient way. Right, the future. Quickly, I'm going to talk about the future. As I said, I'm not going to predict anything. This is more of a wish list from me. These are the things that I would like to see develop over the future. Interfaces for all. This is my main interest in this area, is that I know from decades of talking to people about heating controls that very few people actually control their heating effectively at the moment. Many people do not understand their existing heating controls, and the developments in heating controls over the past 30 years haven't helped. They've probably made that worse, if anything. If you've got a programmable thermostat, and if you've got the time and the manual and you work it out, you can set it to run efficiently. But if you haven't got the time, or you don't understand it, or things change too rapidly, it just doesn't work. I suppose what I'm hoping for here is that companies will develop options for the way that people interface with heating. Some people will want to talk to a system. Some people will want an iPad with sliders. Some people will want to see all those numbers and make decisions on that base. And some people, as I said earlier, want a dial on the wall with a red arrow pointing one way and a blue arrow going the other way. That's the type of interface that people can cope with. Then there's no reason why a smart heating control system can't work off that. And I think that's perfectly possible. I think we are moving from the early phase when the main companies were selling smart tech to people who were into smart tech. They have started to move to a broader audience. And as I see it, there's further to go in that way, because the real potential for this smart technology is to help people who are technophobes, people who cannot manage their existing systems. The smart system can manage it for them. What we need to do to enable that is to provide a range of interface options so that everyone, whatever their preferred means of communicating, whatever their level of technical understanding, can find an interface that suits them. Self-programming. This is on offer to an extent already, but I'm not sure how effective it is yet. But the fact is that if people control their system by turning the thermostat up and down, we in the business know that that isn't how to control a heating system. So a smart heating control system should also know that. It should know what people are trying to say when they turn the thermostat up and down. It should be able to write a program, a flexible program that people can change, but which is based on the way people have been trying to operate their heating over time. And the third thing for the future, this is a completely different, bit of a random tangent really, but there is huge potential here to solve a totally different problem. We are trying to improve the energy performance of homes across the country. We've got to the stage where now we really need to start looking at the millions of older properties with solid walls and older windows that are difficult to upgrade. One of the barriers to upgrading those buildings is that when we insulate a solid wall property, it's not really clear what's going to happen to vapor, moisture as it moves through the building. And there is a risk, if we do it badly, that we cause problems, structural problems for the building. This is a very real problem, and one which we are working on a number of technical solutions to try and make it more effective, make it easier to insulate these older buildings. Bear with me, I'm getting there. One possible, the standard recommendation when you insulate a building like this is, okay, we can put this insulation in here, provided we're careful, but you need to improve the ventilation. You need to increase ventilation. You may need to add mechanical ventilation to avoid the risk of moisture buildup and damage to the building. We don't know how much ventilation is required, so we have to ask people to set it high. We also know that people are likely to turn that ventilation off as soon as our back's turned, because they won't see the moisture problem. They won't know there's a problem until, for years later, the problem arises. Now, a smart heating control system that properly integrated with humidity monitors throughout the house could be programmed so that it manages the building, bearing in mind the moisture risk of that building. So you can program it so that it's, when moisture levels reach a certain level, it increases the ventilation. That will allow us to add more insulation to older buildings safely, and it will allow us to limit ventilation to avoid excessive heat loss, excessive discomfort, excessive power consumption of the ventilation. This is a whole new area as far as I'm concerned that I'm not aware that anyone is really working on yet, but it's something that I think over the next 10 years could radically change the way we retrofit our older buildings. Okay, and that's me done. No, it isn't.
Thanks for that, Brian. That was really interesting. So we have actually had some questions while the presentations were on. Sorry, my screen's not actually moving just now. Is it going on? Sorry, slight technical problem right at the very end of the... there we go. There's a lovely questions and answer screen. So we did have a couple of questions during the presentations, but they were quite specific to people's individual circumstances, and my colleague has been super efficient and has already answered them. So if you had a question, you've probably seen Scott's response already. So just to let you know about our next webinar. So it's be later on this month, and that's going to be on energy storage. That's the only one we've got scheduled at the moment, but we've got planning to have some more. So if you keep an eye on the link at the bottom of that slide, you can follow all our events there. So be it webinars, other events, and just keep an eye on that and see if there's anything that might be of interest to you there. And yeah, all that remains for me to say is thank you to Jon, Sofie, and Brian for presenting for us, and to all of you for joining. So thank you very much. Goodbye.